হ্যালো, তোমরা শুনতে পাচ্ছ?
হ্যাঁ স্যার।
আচ্ছা, আমি শুরু করবো এবার।
হ্যাঁ স্যার।
আচ্ছা, এটা লিখে ফেলেছো?
হ্যাঁ স্যার।
আচ্ছা। So these are the major features of graph search control. Firstly, graph search algorithm continues search simultaneously on all the paths coming out from the start node. That is, if this is the start node S, in the state space graph, there may be several paths coming out from this start node. When we discussed irrevocable control regime or tentative control regime, at a time only one path was explored. At a time only one path was explored. How long? Until a goal node is reached or a dead end or the depth bound of a node is reached. Under that situation, irrevocable control algorithm does nothing. It simply stops, and backtracking algorithm, it backtracks over some node on this currently explored path to continue search in other direction. But here, all these paths coming out from the start nodes are explored simultaneously. So all these paths are explored simultaneously. Firstly, now to do so, it goes on storing all the paths it has discovered from the start node. In case of irrevocable control, the algorithm was so that every time we apply a rule on the currently selected node, a new node is generated, then we compare it with the goal node. If it matches with the goal node, then it's all right. Otherwise, the search continues and nothing is stored. In case of backtracking, what we observed, all the nodes on the currently explored path are stored on a stack. And when the algorithm backtracks one level up on a node which was previously selected, a node from the stack top is removed to implement that. But here, since all these paths are explored simultaneously or searched simultaneously to find a goal node, so if G is there over this path, if G is there, all these paths are explored simultaneously in search of a goal node. So all these paths must be stored. And how this can be stored? To store all these paths simultaneously, we need a tree structure, and that is called search tree. So to do so, it goes on storing all the paths it has discovered from the start node, but not this part of the graph, which has not been yet discovered. Now all search paths are stored as a search tree. Search paths. Now to change the search direction on reaching a dead end, graph search algorithm can directly jump to a node which has already been generated. For example, let this be the search tree. As if these nodes are visited. And it reaches a dead end here. And it can directly jump to any of the leaf nodes of this search tree, which has been generated but not visited. It is unlike the case of backtracking. It is unlike the case of irrevocable control. Now let me illustrate graph search algorithm with an example. Jack, you please add another point with that graph search methods. This will be the first point. Actually, be it irrevocable control, be it backtracking control, be it graph search control, all these we are doing in search of a goal node in the state space graph. And to search a goal node in the state space graph, we have to visit each node of the graph beginning from the start node and to check whether it is a goal node. So this is the basic strategy, and this graph search algorithm provides a sequence of steps of operations to visit all the nodes of state space graph systematically. And there are now these nodes can be visited in two different ways. One is called breadth first search, another is called depth first search. After এই লাইনটা এগুলো লিখেছো তো, মুছে দেবো তো?
হ্যাঁ স্যার।
Before discussing this, can you tell me what is the depth of a node in the state space graph? What is the depth of a node in the state space graph? And which node has zero depth in the state space graph? Please answer.
Sir, the root node or the start node has zero depth, and depth is defined as the distance of a node from the starting node or the root node.
That is the arc length.
Yes,
Length. Right?
Yes, sir.
Okay. Now, if from the start node to a node, if there exists more than one path, obviously its depth, it will have more than one depth.
Yes, sir.
Isn't it?
Yes, sir.
Okay. Okay. Now, now initially let us assume that every node is connected to the start node with a single path for the sake of simplicity. Now, under breadth first search, nodes of smaller depths are visited first, beginning from the start node. And such, nodes of higher depth are visited first, beginning from the start node. Now, let me illustrate this with an example. I shall first illustrate breadth first search. Let this be a state space graph for some problem where A is the start node and G is the goal node. And initially all the arcs of the state space graph are shown with dotted line because this graph is not stored explicitly, rather it is stored implicitly. During state space search, we store the start node, goal node, and the set of rules by applying which the nodes of the state space graph can be generated. That's why this state space graph is initially shown with dotted lines. Now to conduct graph search, conduct graph search, we need two lists. List means it can be implemented with an array, which will have a front end and a rear end like this. So this is a list which can be implemented with an array. I have earlier explained it. Okay. The graph search algorithm, it requires two lists. One is named as open. It is to store nodes which have been generated but not visited like this. Let this be node, a node this here. And close to store nodes which have been visited. That means generated and then visited. So, because the nodes which we generate and visit must be stored somewhere. Otherwise, if we find that the depth bound has reached, we will not be able to change the direction of search. আচ্ছা এটা মুছে দিচ্ছি এই অংশটা
হ্যাঁ স্যার
So initially, both of these lists are empty. That is open and closed. Now, the open list, it stores the nodes which have been generated but not visited. That means those nodes have not been compared with the goal nodes. So every time this graph search algorithm to continue search, it will select a node from the open list. It will first mark it visited and then compare it with the goal node. So these are the major steps. major steps that select node N from open list, and I should add the 0th step here. The 0th step is send start node to open. This is the 0th step. So first select a node A from open list, and after selecting a node from open list, it should be marked as visited, and to mark it visited, store it in a separate list that is closed. So send N to closed, then check if N is equal to gold node. If N equal to gold node, then this search algorithm will stop. Otherwise, what we will do, if this be the node A, we will generate all its successors N1, N2 and N3 to explore further portion of the state space. So generate successors of N and send them to open, and then go to step 1, that is again select a node N from open, and in this way the graph search algorithm will continue until it finds a goal node or the entire open list gets emptied. I shall explain this, but this is the major steps of operations.
Okay, sir.
ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা, মুছে দিচ্ছি। তোমাদের আমি টেক্সট বইয়ের নাম বলতে ভুলে গেছি। তা তোমরা কি কোনো টেক্সট বই থেকে পড়া শুরু করেছো?
না স্যার, সেরকম করে স্টার্ট করা হয়নি।
অন্যরা?
স্যার টেক্সট বইয়ের নাম ফার্স্ট দিন বলেছিলেন, কিন্তু ঠিকঠাক আর খেয়াল নেই। আরেকবার
আচ্ছা ঠিক আছে, ক্লাসের শেষে বলে দেবো, আর ক্লাসটা করে নি। হ্যাঁ, টেক্সট বইয়ের ছবি তুলে পাঠিয়ে দিচ্ছি। So to search this graph, we will first send node A to this open list. A will be placed in this open list since it is the start node. Then what we will do? We will remove A from open list and we will mark it as visited, so A will be placed in the closed list. That means if this be the A, pictorially we will mark it as visited. After marking A as visited, we will compare it with goal node. Here it is not equal to goal node. So what we should do? We should generate all successors of A. And after generating all successors of A, those successors will be placed in the open list. Now here I have used solid lines because these paths have been explored, all these successors have been generated by applying suitable rules, by applying a suitable rule on node A. And after these two successors are generated, they will be placed in the open list according to that algorithm. Now there is a step of operation in the algorithm. Go to step 1. In step 1, what will happen? This will again select a list. This will again select a node from the open list. Now we are discussing about breadth first search. We are discussing about breadth first search. So the node with lesser depth will be selected first. Now there are two nodes in the open list, B and D. Both of depth 1. B has a depth 1, D also has a depth 1. So any of them can be selected. Let us arbitrarily select node B. And as soon as you select node B from the open list, what we will do? We will first mark it as visited, and for that we have to set this node to closed list. So at the first instance A was selected, and in the second instance now it will again be compared with the goal node, and it fails to match with the goal node. So what we will do? We will generate all its successors. E and G are the successors of B. So we have to generate them. E and G. And after generating these two successors, we have to set them in the open list. Do you agree with this?
Yes, sir.
Achha. Now next time, if you follow the algorithm, the step is go to step 1. That means select one node from the open list. This is the open list. 3 nodes are there, D, E and G. And basically all these are the leaf nodes of the search tree, which has been generated as the search goes on. Now since we are following breadth first search, every time we will select a node with lesser depth first. So out of D, E and G, D has the least depth, that is a depth of 1, whereas E has a depth 2 and G also has a depth 2. So next time D will be selected. So next time from this open list D will be selected. This is the node D. So this will be selected. It will be marked as visited. So D has to be placed in closed list. Then we will compare D with the gold node. It does not match with the gold node. So what we should do? We should generate its successors. In the graph, we find that the successor of D, which is G, has already been generated as the successor of D. So it is already in the search tree. So no need for generating G anymore because G has already been generated as the child of node B here. So what we will do? What this algorithm will do? It will go to step 1. And in step 1, it will select a node from open list of lesser depth. And E is one such node. So next time E will be selected. So after E is selected from open list, it will be marked as visited and it will be placed in the closed list. Then it will be compared with the goal node. It fails to match with the goal node. So its successors F and C will be generated. F and C. And after generating the successors of E, this F and C should be placed in this open list. F and C. ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা। ঠিক কি করে রইল এটা তো মানে ফোর্থ টাইম এটা সিলেক্টেড হয়েছে এটা 3 লিখেছিলাম আমি বলবে তো ঠিক কি করে রইল বুঝতে পারলাম E fails to match with the goal node. So its successors are generated, they are added in the open list, and next time following this go to step 1, we will select one node from the open list, and since we are following breadth first search out of G, F and C, G, A and C, we will select the node with least depth. So next time this node will be selected. So this will be selected. And after G is selected from the open list, it will be first marked as visited. That means you should send it to closed list, and then it will be compared with the goal node. So it matches with the goal node, and here the algorithm will stop on finding the goal node. So this is an illustration of breadth first search. Now this is the original graph. Now let us try to find how the nodes in the graph are visited compared to the backtracking search, because on the same graph we applied backtracking search earlier. So it begins from node A, that is the start node. Then it visits node B. It fails to match the node B with the goal node. Now, after it fails to match node B with the goal node, it selects node D. In case of backtracking to select node D, the search algorithm has to backtrack to node A, then it could select node D. But here it could directly go to node D. Since the portion of the state space which has already been searched, it is stored in the form of a tree. So it will go to node D, and then from node D, if it fails to match node D, it need not backtrack to node A. It can directly jump to node E. And when it fails to match with the node E, it need not backtrack to node B, that is the parent of E. It can directly jump to node G. So I have already mentioned that graph search algorithm basically provides a sequence of steps of operations to be followed to visit all the nodes of a graph in a systematic manner, beginning from the start node. And why do we need to visit all the nodes of a graph in a systematic manner? Because we want to find the goal node in the graph. And breadth first search, since it always selects a node with smaller depth first, so it first visits all the 0 depth node, then it visits all the 1 depth node, then it visits all the 2 depth nodes in this way. That is, breadth first search cannot visit So breadth-first search cannot visit a node of depth I+1 until all nodes up to depth I have been visited. Get my point?
Yes, sir.
Next is, what should be the space and time complexity for this breadth-first search? Space complexity and time complexity, the order. Now, you should note here that if the goal is at depth D, breadth-first search should continue search the state space up to depth D, at least. Definitely up to depth D, it has to continue search. Now when it continues search up to depth D, during that search it has to store a search tree of depth D.
Yes, sir.
It has to store a search tree of depth D. Let us get search tree of depth D.
স্যার দুটোই কি O of B to the power D হবে?
আসছি if B be the average branching factor, then the number of nodes in this tree will be proportional to B to the power D.
Yes, sir.
So both will be of the order of B to the power D. Time and space complexity. In case of backtracking, we observe that the space complexity was of linear order.
Yes, sir.
It was of
Depth bound.
O of D. Because we had to store only the correctly explored path. But here we have to store the entire search tree. So it is of the both complexities are of the order of B to the power D. So breadth-first search is not worth for practical
Feasible.
problem.
Not feasible.
Not feasible. For a goal of sufficient depth, it will not be practically applicable. Though this algorithm will theoretically work, it will eventually provide you the solution. That may be after 1 year, that may be after 2 years, that may be after 1,000 years, even with the fastest computer. But the point is this. It is not practically applicable. So again, we need AI here. But before explaining how we can apply AI here, I want to explain another kind of graph search method that is called depth-first search. Depth-first search. Next day I shall explain depth-first search. That is on next Monday. ঠিক আছে?
স্যার ডেপথ ফার্স্ট সার্চটাও তো সেই ব্যাকট্র্যাকিং এর মতোই হচ্ছে।
হ্যাঁ এক্স্যাক্টলি সেটা তো সবাই এখন বুঝবে কিনা জানি না, সেই জন্য ওটাকে আরেকবার এক্সপ্লেন করে দেবো। ঠিক আছে? ঠিকই। আমাকে দেখো, আমাকে সবকিছু জিরো লেভেল থেকে পড়াতে হচ্ছে। আমি শুরু করেছি অ্যালগরিদম কাকে বলে, আমি শুরু করেছি ডেটা স্ট্রাকচার কাকে বলে, আমি বলেছি স্ট্যাক, কিউ, এসব ট্রি এগুলো কাকে বলে, গ্রাফ কাকে বলে, এগুলো কি করে কম্পিউটারে স্টোর করা যায়, তারপরে কমপ্লেক্সিটি বলেছি, তারপরে অ্যাসিম্পটোটিক কমপ্লেক্সিটি বলেছি। সো সুতরাং আমাকে তো জিরো লেভেল থেকেই সবকিছু বলতে হবে। এটা ঠিকই যে ডেপথ ফার্স্ট সার্চ ইজ বেসিক্যালি ইট ইজ এ ব্যাকট্র্যাকিং সার্চ। যাই হোক, আমি নেক্সট দিন ডেপথ ফার্স্ট সার্চটা এক্সপ্লেন করব। আফটার দ্যাট আই শ্যাল এক্সপ্লেন হাউ এআই ক্যান বি অফ হেল্প আন্ডার দিস সিচুয়েশন।
ওকে স্যার।
ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা, আমি না ওই বইগুলোর ছবি তুলে তোমাদের পাঠিয়ে দিচ্ছি, বইয়ের ফার্স্ট পেজগুলো।
ঠিক আছে।
ঠিক আছে? আচ্ছা
হ্যাঁ স্যার।
ঠিক আছে। আজকে এই অবধি থাক।
ওকে স্যার।